Every network, no matter how well built, eventually fails. Given that inevitability, teams that chase it will never fail are chasing the wrong goal entirely. The question worth asking instead isn't whether a failure will happen, it's how quickly the team gets back to a working state once it does. That question has a name and a number: mean time to repair, or MTTR, the average time across many incidents between a failure starting and it being genuinely resolved. The clock for that number starts at a precise, unforgiving moment, the instant the failure actually happens, not the moment someone happens to notice it. Between that start and the eventual finish sit distinct stages, and each one can be measured, practiced, and improved on its own: detect, diagnose, and repair. Repair itself has a subtlety most people miss. It isn't finished when the fix is applied. It's finished when recovery is actually verified, not merely hoped for. Two teams can suffer the identical failure on the identical system and come out with wildly different MTTR. And that gap is exactly what separates a resilient operation from a fragile one. A wrong goal, a better question, 4 measurable stages, and a real gap between teams. Let's walk through exactly how MTTR gets measured and improved in slow motion. Take 1. A team obsessed with preventing every possible failure pours enormous effort into an unreachable goal, while spending far less energy preparing for the failures that will happen anyway. MTTR reframes the whole effort. It accepts failure as a certainty and asks a more useful, more answerable question: how long does recovery genuinely take, on average, across many real incidents? The clock begins the instant a failure actually occurs, a link goes down, a service starts erroring, a router misbehaves, regardless of whether anyone is watching at that exact moment. That starting definition matters enormously. If a failure sat unnoticed for 10 minutes before anyone reacted, those 10 minutes count fully against the final number, exactly as they should. Stage 1 is detection. Some automated system, a monitor, an alert, a threshold breach, has to notice that something has actually gone wrong. Strong detection is often the cheapest win available. Shrinking the gap between a failure occurring and a human learning about it can cut meaningful minutes off MTTR before anyone even starts investigating. Stage 2 is diagnosis. Turning something is wrong into here is exactly what's wrong and why. This is frequently the slowest, most unpredictable stage of the entire process. A dozen plausible causes might explain the same symptom, and ruling them out one by one, under pressure, with incomplete information, is exactly where experience and good tooling earn their keep. Stage 3 is repair. Applying the actual fix, whether that's rolling back a change, rerouting traffic, or replacing failed hardware entirely. Crucially, repair isn't declared complete the moment the fix goes in. It's declared complete only once recovery is actually verified against real signals, confirming the system genuinely works again. That's exactly where the clock stops, at confirmed recovery, not at the optimistic moment someone typed the fix and hoped for the best. Every single one of those stages can be practiced in advance, through rehearsed drills, simulated incidents run on a calm Tuesday afternoon, specifically to shrink real MTTR later. Put two teams through the identical failure scenario and the gap becomes visible immediately. One team detects, diagnoses, and repairs in minutes. The other takes hours doing the exact same underlying work. That gap is precisely what customers feel and remember, not whether a failure happened at all, but how quickly and calmly it got resolved, which is what actually earns lasting trust. MTTR is often discussed alongside a close cousin, MTBF, mean time between failures. Both numbers matter, but MTTR is the one a team has far more direct, practical control over improving quickly. Some teams split MTTR further into its component parts: mean time to detect, mean time to diagnose, mean time to repair, specifically so they know which single stage to invest in improving next. Good incident tooling exists almost entirely to compress this number. Automatic alerting compresses detection, clear runbooks compress diagnosis, and tested rollback paths compress repair itself. The honest trade-off: Chasing a lower MTTR can tempt a team toward quick, superficial fixes over slower, more thorough root cause work. The best teams track both the speed and the durability of every fix. Accept that failures happen, start the clock at the real break, detect fast, diagnose the true cause, repair and verify, then practice the whole sequence before it counts. That's why MTTR is the number that really matters. Hidden machinery shown. Next time an outage gets resolved calmly and quickly, you'll know a practiced MTTR, not luck, made that happen. Check out our other videos and follow how it all runs for more. See you next time.